This product training module highlights transient blocking units as an important circuit protection technology available to the market. We will review the operation of the TBU device, product offerings, target markets, and solutions with a focus on RS-485 port protection as an application example. By the end of the product training module, we hope the viewer will have a better understanding of the operation of a TBU device and the use of the TBU device in a typical application providing enhanced circuit protection performance. Bourns offers world-class technology and applications expertise that is the result of many years of circuit protection engineering, design, and support. Bourns' global reputation for extensive application knowledge, quality products, innovative protection strategies, and a wide range of technologies ensures that we can provide the right circuit protection solution for your needs. Depending on the customer's requirements between the cost of low-level circuit protection versus the transient threat level, choosing the right protection level at the design phase can bring significant savings down the line. The basic overvoltage and overcurrent protection scheme used for a typical signal port is shown here. The TBU device is placed in series to block transient currents and provide voltage isolation. OVP2 limits the voltage at the input to the protected circuit and provides a path for transient current until the TBU device is triggered and transitions to the full blocking state. OVP2 may not be required if adequate protection is designed into the protected circuit. After the TBU HSP is triggered, OVP1 limits the voltage across the TBU device to a safe level and also provides a current path for the remainder of the transient event. A GDT can be chosen for OVP1 when used to protect high-speed communication lines such as DSL, Ethernet, or LVDS. An MOV can be used for OVP1 for slower speed applications such as voice or RS-485. The OVP1 device should be chosen so that it does not trigger during power cross tests. The TBU is a silicon-based solid-state resettable device, which is placed in series with a signal path. The TBU device trips in approximately 1 microsecond, T-block, once line current exceeds the TBU device's trigger current, or I-trigger. When in the tripped state, the TBU device restricts line current to less than 1 milliamp. In this state, the TBU device will block all system voltages and any other voltages, including the surge, up to rated limits. After the surge, the TBU device resets when the voltage across the TBU device falls to the V reset level. The TBU device will automatically reset on lines which have no DC bias or have DC bias below V reset, such as unpowered signal lines. If the line has a normal DC bias above V reset, the voltage across the TBU device may not fall below V reset after the surge. In such cases, special care needs to be taken to ensure that the TBU device will reset. Otherwise, an automatic or manual power down will be required. The TBU device performance is shown here in Lightning and AC power cross. During the lightning pulse, the blue current line is rising to the trip level, I trip. The TBU device blocks the current signal even when the voltage continues to increase. During the AC power cross, the TBU device turns on and off every cycle, and the blue line shows the TBU device triggering in both positive and negative pulses. The impulse speed of the TBU device is shown here, where the reaction time on the green current line shows a limit response of 100 nanoseconds, with a duration of 800 nanoseconds. A key feature of the TBU device here is the low 100 nanojoule let-through energy that passes through to the downstream circuitry. This low energy signal provides opportunities for IC designers to design smaller ICs with lower energy dissipation. The TBU device is typically placed in series between the port and IC. As the Bourns TBU HSP has no connection to ground, The only capacitance added to the signal line is the parasitic capacitance from the device mounting pads to ground. The capacitance can be minimized by eliminating ground plane below the device on the printed circuit board. This minimizes the effect that the TBU HSP will have on the bandwidth of the protected circuit. Here you can see the low insertion loss of the model TBU CA085300WH device in a 50 ohm LVDS test circuit application up to 3 GHz. Bourns has released a new generation of TBU products in 6 product families. For general use applications, the TBU DF series offers a dual bidirectional TBU device with a choice of 2 impulse voltages and 5 trigger currents. The TBU CA series offers a single bidirectional TBU device with a choice of 5 impulse voltages and 5 trigger currents. The TBU CA-Q series of devices is the AEC Q101 compliant variant of the TBU CA series. So far, 4 TBU CA devices have been qualified to be AEC Q101 compliant. The TBU DT series offers a dual unidirectional TBU device with a choice of 2 impulse voltages and 4 trigger currents. For specific applications, the TBU DBQ series offers a dual bidirectional TBU device with a choice of 1 impulse voltage and 1 trigger current, and it's AEC Q101 compliant. The TBU PL series offers a dual 50 ohm bidirectional TBU device with a choice of 4 impulse voltages and 2 trigger currents, and an added feature of both voltage and current triggering. The TBU RS series offers an integrated solution for RS-485 port protection. In addition to providing the same level of protection as the discrete solution, the TBU RS helps reduce the component count, thereby saving board space. Circuit protection is a critical parameter in some markets and applications. TBU devices used in conjunction with Bourns overvoltage products provide superior circuit protection. Here's a list of applications where a TBU device can offer superior circuit protection. In the telecom market, Bourns' extensive product portfolio offers a complete circuit protection solution to required standards in T1E1 interface, VDSL, voice and gigabit Ethernet ports. For the industrial market, the combination of TBU devices with TVS diodes, MOV or GDT products ensures that high surge protection standards are met while data transmission rates are also maintained. The new TBU RS device is an integrated solution for RS-485 port protection. This approach not only ensures that high surge protection standards are met while maintaining the data transmission rates, but also reduces the number of components on the PCB board, thereby saving space. For the automotive market, the AEC Q101 compliant TBU DBQ series matches the protection needs of battery sensing balancing applications, such as those in new battery management systems, BMS. The TBU CAQ series offers a single bidirectional TBU device with 3 impulse voltage and 4 trigger current options. In this specific example, we evaluate the advantages and benefits of the TBU device in an RS-485 application. On the left, you can see the traditional 485 circuit diagram showing 2 10-ohm resistors and 2 12-volt TVS diodes. While this solution meets RS-485 transmission protocols and fulfills lower tier protection, the disadvantage for some RS-485 applications with potential surge transients is that the solution does not provide any AC power cross protection, and the 2 10-ohm resistors are not resettable when they're damaged. For the RS-485 application that requires high-energy surge protection, the circuit on the right with TVS, MOV, and TBU devices should be considered. This solution offers resettable AC power cross protection, irrespective of surge duration or rate of repetition, has no let-through energy to sensitive downstream chipsets, and provides wide operational bandwidth for high-speed data rates. The TBU RS series provides a similar level of protection with the added advantage of lower bill of material component count and reduced board space utilization. Here, electrical performance data on the RS485 solution using TBU high-speed protectors, TBS, and MOV products is shown. Reaction to ESD per IEC 61000-4-2 and surge 1.2 microseconds rise time and 50 microseconds fall time with 5 kilovolts peak voltage are shown on top, while the graphs below show responses to AC power cross under 120 volts RMS and 28 volts RMS, demonstrating the TBU device operating as expected with lower energy let-through and fast resetability. Based on ADI's application note, there are 3 different EMC compliance solutions. Each solution provides a different protection capability. The configuration in Protection Scheme 1 is CDSOT23-SM712. The configuration in Protection Scheme 2 is the combination of TISP 424OM3BJR-S, TBU-CA065-200-WH, and CDSOT23-SM712. Once the TBU device is used in the circuit, the transient voltage can be up to 4 kilovolts, level 4. If the GDT is accompanied with the circuit, the transient voltage can be above 6 kilovolts, level X. X can be any level, above, below, or in between the others. The level shall be specified in the dedicated equipment specification in accordance to the IEC standard. The configuration in Protection Scheme 3 is the combination of 2038-15-SM-RPLF, TBU-CA065-200-WH, and CDSOT23-SM712. Here are some TBU HSP design tools. If you're curious and would like to know how powerful TBU high-speed protectors are, just follow the links. Information about the RS485 evaluation boards and the demo videos can be found here. Bourns TBU high-speed protectors offer high-density integrated component technology and enhanced surge protection in small-sized packages for high-speed communication applications. Continuous product development enables Bourns to provide circuit protection solutions for changing market requirements. Bourns circuit protection semiconductor products can bring significant benefits and enhanced performance to your application. Visit www.bourns.com for more details.